Now I want to show you when you're asked to verify if two functions are inverses of each other, what do? Well, let's say we're given the functions f of x is 3x minus 5 and another function g of x is x plus 5, and we were asked to verify that they are inverses. So as before, where we were actually finding the inverse, for instance, you would have been given f of x is 3x minus 5, and you would have found the inverse, and then that would be your answers to that. Here, we're actually given the function, and then they're giving us another function and asking us, are they inverses? So one way you could do it is to actually find the inverse of f of x and then compare it to what g of x is. However, when in math they're asking you to verify two functions that are inverses of each other, that's not what they want you to do. They want you to use an algebraic method where we're actually dealing with something called composite functions. Okay, and when we deal with composite functions, if you remember, that is when we have f of g of x. So how does that work? Well, and what we're looking for too is when we do that, if we do f of g of x composite function and simplify it, and it comes out just to x, then that verifies. If it's yes, then we know that yes, they were functions. Okay. Now, how do we do with f of g of x? Well, remember, let's simplify it. Back when you find the function, I showed you given the function f of x is 3x minus 5, and then the question says f parentheses 2, so f of 2. Well, of course, you plug in 2 everywhere you see an x in the f of x equation. So if the equation was 3x minus 5, I'm going to write 3. I'm going to replace that x with a 2, because that's what I put in little parentheses on the f of x. And then I'll finish it by writing minus 5, and then I can calculate that. Well, we're doing the same kind of thing here, but instead of putting in a number for the f function, notice how we have f of g of x. So we're really just going to put in whatever g of x is. So it's an equation, it's a function, but we're going to put that whole thing into the f of x function wherever you see the x, right next to that 3. So what is the g of x? Well, the g of x is the same as x plus 5 over 3. So that's what we're going to be putting into the f function. We're going to put in x plus 5 over 3 using that function up there. So we'll write it as 3, because there was a 3 there. Then instead of writing the x, I have a parentheses with that x plus 5 over 3 in it. And we'll write the minus 5 after that. So when we simplify that, we get the 3 cancels the 3 in denominator. So you simply get x plus 5 minus 5. And notice how that simplifies to x. So yes, that means that they were inverses of each other. Now let's take a look at another example. Yes, they were inverse of each other. Let's take another example where we're given a square root function for f of x, and they give us g of x is x squared, and they're asking, are these inverses of each other? Or they're asking, verify that they are, show the work. So we're going to do the composite function again, where we have f of x, f of g of x, and we got to put in what is g of x. Well, g of x is the function x squared minus 7. So that is going to go into our parentheses there. F of x squared minus 7. Go to your f function, the square root of, and then I'm going to put in, instead of the x, I'm going to put in parentheses there, the x squared minus 7 that I'm replacing it with. Don't forget to add that plus 7 that's in there as well. So when we do this, what happens? Okay. So just note too, that 7, I just write the plus 7, that is not under the square root sign. Just the x squared minus 7 in parentheses is under that square root sign. Okay, so what do we do here? Well, we know that the x squared is only left alone in there because we have so now we're putting in the f of the x squared minus 7 into the f formula. And then we've got square root and replacing that x up there with an x squared minus 7 in parentheses. And don't forget we have to add 7, which still that's underneath the square root sign. Well, we don't really need the parentheses there for the x squared minus 7. So when you combine these, the minus 7 and plus 7 will cancel out. So we just have x squared left there. And it's under the square root sign, so the square root will cancel the square. So you're simply left with the variable x. And since we did that composite function and came out with just x, then that verifies that, yes, they are inverses of each other.